Okay, so this is issue number 33 where I will be cleaning up the Win32 window. So I'll start by going to shared memory, and I'm going to make it so that there's a fatal message, and that'll be essentially all of the bytes that come after the initial bytes. So let's create a const up here, EVT shared mem data start. I can use the size of there, but keep it simple. So we're going to return a string. I'm going to cast the E, and we want to say the shared mem data start to the end. And that's what's going to be sent back from that. So now that we have a fatal message, we can go to window.go and check for that fatal message when we create the window. So if w.evt shared is fatal, then rather than panic, we're going to return errors.new, and we will return window or error. Make sure that's included. Oh, it is. Okay, that means when we call this new function, we will need to check for that error, which I believe happens in host since it's not finding it. And here we're going to return either host or error. Here. I'll say when error, if it's not nil, return that. Okay. And then we go to main where we create the host. And here we can get the error. And then we'll panic up here because this is all the way at the top. Cool. So now we're going to be able to create a window and deal with the error that comes out. So I'm going to close all these guys and then go to win32.h. Now inside of the win32.h, we want to be able to print out a fatal error. So void, we'll say write fatal. We'll take in the message. We're not going to do this. We'll take in EVT mem, shared mem as a const or as a char star, and then the size of it. And here we're going to include string.h and do event shared is fatal. And we're not going to do a memcpy. We're going to do a strcpy_s. Cool. And now we can use the write fatal wherever we're doing a fatal here. ESM size fatal below window. I think that was the only fatal that we currently have. So now we have the write fatal. We're going to test to see that write fatal is working. And this does not need to return anything. I don't know why it's red there. Oh, because the terminator. So we're going to try write fatal. And we're just going to write this is a test. Make sure we're getting this from C. Okay, so we get all the way to the top and we get a panic, but we're getting a bunch of zeros So that copy must have copied incorrectly. So we have the message here. We are doing copy to the destination, which is event shared memory plus the data start, then the size in bytes, and then the source message. Okay, we might be hitting a race condition where it's picking up on the other thread because the fatal was written, so we're going to write the data first, and then we'll write the fatal out. Yep, there we go. This is a test. So that's all that was. No big deal. Alright, so that sets up our fatal messaging out. The next thing I need to do is clean up the rest of this this code. I want to move the switch statement up into this window proc function, and I want to make writing to shared memory a little more clear. Okay, so we can delete the fatal message, because we're no longer going to need that. So now we'll go down here to our switch statement where we have all of our cases, and we're just going to cut those cases and move them directly up into the window proc. Also, we're going to fix this return 0 here. Put it up here for now. These breaks, so this return 0 is just to prevent it from getting down, falling through to this def window proc. Which I don't know if we need to be doing that. That may prevent the quit from being called. But what we need to do is get that shared memory over into this window proc function, and we can do that by attaching user data to the HWND handle, window handle. Get rid of that standard IO there. So before we do a show window, we can do set window long pointer A, and we would use ESM, but we also want to know the size of it as well. So we should create a structure similar to the input event. Do a type def struct, and we'll set we'll call it shared mem is fine. And then we can do chart pointer EVT, or we just say shared mem int size. And one thing we can do is I want to make this input event a little have some of the other fields we're returning. So we're going to do a union for the shared memory and also input event pointer EVT. Now for this guy, I am going to add in a couple of extra fields here just to flesh out the full type. So I'm going to do a union uint 8t. This is going to be the write state. And then we'll do int32t buffer. This just fills out those 4 bytes we have at the beginning of the union, or at the beginning of the structure. And the next one is going to be the event type. So we're going to do a uint32t evt type. And that's what we'll do. So the first 4 bytes is the write state, the next 4 is event type, and then the ones we expect. And we do a little list, pointer arithmetic now, that we're using that. So at this point we have this shared mem structure, which we could use in the place of ESM. However, I'm going to set that up just before we set the long pointer. I'll do shared mem. SM is fine. Is going to be equal to the ESM and the size. And the long pointer we're going to pass in is going to be the address of SM. So now that means we can get the shared memory pointer from our window proc. So shared mem pointer, okay, it pretty much knew what we were going to do. Now this shared memory pointer may be null the first couple of times we come into this, so we're going to check for that. So if SM is not equal to null, then we're going to go down here and do our big old switch statement. So that sets that up. Now we want to deal with the mouse event. So we'll just move this function up so we don't have to make a function prototype. We'll move it there. And what we're going to do is we're going to take in the event, and we're not going to pass in the message because we're using the L param on both of these, and we don't have the message anymore. So I'm just going to grab this L parameter, pass it directly in like that, and we're going to change IE to EVT pointer, and that will solve that. So now down in our set mouse events, we're going to pass, instead of IE, we have access to SMEVT, and we're not going to pass message, we're going to pass in UMSG here. That's the unsigned ID of the message. So we can just copy this and paste it on all these usages here and delete out the returns. And this wparam is just going to become, or message wparam is just going to become wparam. Wparam here as well. This is just lparam, and IE key ID is going to be EVT key ID. Get rid of that. And these are also going to be, oh, not EVT, SM EVT key ID. The shared memory. SM EVT and wparam there. So let's make sure we have our breaks on all these cases. Break, 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 and return on that one. Okay. So now that we've copied that over, we need to come down here, and I essentially want this peak message just to go straight into translate and dispatch. So we're going to create a helper function to make this part readable. We'll just create void shared memory wait for available. Take in a shared memory pointer SM, and we can just change this to SM EVT write state. Pass our SM into there, as we'll, oh, we won't have SM here. We're going to have the address of SM here. So next, this is setting up the writing and the quit and everything else. So I'm just going to grab this section. So we're going to spin lock, and then we're going to translate the message. And we're going to come up into here. I'm just going to paste this underneath the destroy real quick. We're going to say that we're writing at the top, and then we're saying if it's a quit, we set the shared memory here. We can actually put this on the destroy request, and then we're going to write the message type. We don't need to do this anymore. because we're going to just write out the entire event directly by assigning its values. So there's no need for a memory copy. There's a need for setting the message type. So up here we'll do sm evt type is equal to uMessage. We don't need that or this or that or this. We do need the written. So we need to put written down at the bottom. And we only want to mark it as written in the case that it's not a quit. So if SM event type is not equal to quit, and of course, shared memory quit, then we're going to do SM evt write state is equal to written. I'm probably going to make a helper function for that. Void shared memory set write state. So shared memory, and we only want to do this if it's not quit. So if or fatal. So if SM event state is not equal to shared mem quit and it's not fatal, then we're going to write it. I'm just going to say, just to make this shorter, that's a uint8 t state is equal to the write state. So it takes up less line space. So now we can use this instead of, so we say SM and written. And we're going to do the same thing for the quit. Oh, this should become a W param. Come up here to the quit. I'm right clicking apparently on this laptop. Quit. And we want to do it again for writing. Okay, let's test this out. So I've got a state is wrong kind of symbol, error state redeclared. Okay, that's just because it came in, so I'll just change this to SM state. SM state. Okay, let's try that one. Okay, that one just compiled and closed immediately, so I think the write state's not happening or the available state's not happening. So we're going to go down to where we do set these other states and use our helper function. So here we'll do shared mem write state. We don't want to write available, we want to write written. This ESM data is being used down here, but we can actually just do sm.event event type 0 here and get rid of this, get rid of that, and then copy this down. Let's make sure this compiles. I don't expect any change in behavior. Okay, yep, no change in behavior, so I'm gonna look through this and see where we are not properly setting the state and where it's exiting. Well, I'm pretty sure I found it. This is a silly mistake. I was using SM even though it could be null. So let's try it with that guy. Moved into the null check. Okay, so now the window is showing. Make sure it closes. When it closes, it stops debugging. So that puts us right back to where we were, but now in a much more clean state. We'll want to also set up OpenGL to work with this. So that's mainly why we wanted to do the cleanup, is just to make that a little bit easier to work with once we add that in. Suppose while we're here we can set up the X11 state as well, since it's doing the same input event stuff here. We're going to replace the IEs with our new structure that we now have access to, which we can set up here. Let's see. Create the window, map the window. So we'll do it right after we set the protocols. Shared mem is SM is equal to EVT shared mem and size. So we can run this as written, and then we can look for where we're doing writing. Put that in there. We don't need this anymore, and we don't need IE. So all of the IE dots are going to be replaced with sm.evt pointer. Okay. Then we're going to need that written at the end again. And of course, we don't have to check for the quit here, because that happens internally. You can just paste written at the end there. And then of course, the one for quit. Bring up not a new PowerShell. We can bring up a new Windows subsystem for Linux. To the build folder and check out the build sh. I'm going to grab this guy so that I can build it. Go build, and we'll see if we get any errors building for Linux. Oh, this Linux doesn't have X11 set up. Well, actually it does. I just need to pass it. I need to call the export for the compiler flags, and then do that. And we'll see if we have any errors with what we changed. Nope. So let's try to run it. /kaiju. So we have our X11 window here, and we'll try to close it, and it closes just fine. But this is still running, so maybe there's an issue there. I can check into a little bit further on the Linux computer, but it still builds and everything. So that's it for this cleanup.